Welcome to my talk from data loaders to batch resolvers. My name is Aileen. I live in San Francisco with my 2 kids, my dog, and my husband, who is hopefully surviving while I'm out here. I'm an engineer at Airbnb, where for the last 5 years or so, I've been working on something called Viaduct. So Viaduct is essentially Airbnb's GraphQL server. And if you were here on Monday, both my colleagues, Rami and Adam, also known as Skevy, gave talks about Viaduct, which were great. If you missed them, I highly recommend that you go and view the recordings. So I lifted these stats from Adam's slides, and basically, Viaduct has been adopted very widely at Airbnb. It's a pretty mature platform at this stage, and we've learned a ton over the last 5 to 6 years of building Viaduct. And we're developing a new version of Viaduct, which we will be open sourcing, called Viaduct Modern. And this will be released in the next week or so. So Rami's talk focused on sort of the engine aspect of Viaduct. And Adam's talk talked about sort of the history and the evolution of Viaduct and how we avoid some of the pitfalls of being a monolith. Today, I'm going to focus on another aspect of Viaduct, which is the developer API, and specifically how we solve the N+1 problem using a feature called batch resolvers. So most of you here are probably already familiar with the N+1 problem, but I'll describe it briefly for those of you who aren't. Suppose you're a product developer at Airbnb and you're building a feature like this where you show a list of recommended Airbnb listings. So here is a dramatically simplified version of a query and schema used to power this feature. In the schema, we have a root query field called recommended listings that returns a list of listings. And also a listing no type that has metadata about the listing, like the title. And here our query fetches the first 3 listings along with the ID and the title. So here's an example response with 3 listings. And in order to create this response, we first call the recommended listings resolver, which makes a call to the recommendation service to get back a list of listing IDs. And then for each of those listing IDs, we call the listing resolver, which in a naive implementation directly calls the listing service and fetches a single listing. So, obviously with a list of size n, this results in n separate calls to the listing service, which is super inefficient and something we want to avoid. Ideally, we can batch all of these requests together instead. So this is a solved problem, right? How many of you here have used data loaders or at least know what they are? Yeah, pretty much everybody. And this is what we use at Airbnb as well. So data loaders solve the N+1 problem by combining multiple fetches into a single request. And so here we can add a listing data loader. And then our listing resolver can call this data loader instead of directly calling the listing service. And then this will, handle batching the requests. So this solves the problem in theory, but what we found at Airbnb is, like I mentioned, we have hundreds of developers working within Viaduct and contributing to our GraphQL schema. And those folks haven't all attended GraphQL Conf. They have varying levels of familiarity with GraphQL. And for most of those people, data loaders are a source of confusion. They oftentimes aren't aware that they need to use data loaders or have a hard time using them. And so this is a screenshot from our support Slack channel where, actually, true story, as I was making this presentation, I was thinking about how do I tell this story? And I got this question from one of our developers, and they were basically like, hey, we switched to using some new schema with a new implementation, and all of a sudden we're seeing crazy fan out to this downstream service. What's going on? And of course, the implementation forgot to add a data loader. So here is the metrics that they shared with us. As you can see, they flipped a feature flag, and all of a sudden there's a 4x increase in the number of downstream calls. So this is not an isolated incident. It's a very common performance problem. So the issues that we've seen at Airbnb with data loaders is that they're often hard to understand, hard to use, and because of that, they're often only added retroactively after alerts go off in production. So in Viaduct Modern, in the version that we're going to be open sourcing, we provide a more ergonomic solution to the N+1 problem called batch resolvers. Before diving into batch resolvers, I'll first give an overview of what resolvers look like in Viaduct. So Viaduct is a schema-first system, and developers first define their schema and then provide resolvers for them. So naturally, the schema is the source of truth for what resolvers exist. And there are two types of resolvers. The first are field resolvers, which you can indicate by adding the resolver directive to your field. And then the second type of resolver is the node resolver. So for every object type in the schema that implements the node interface, there's a corresponding node resolver implementation. So that's the schema, and now we'll talk about the Kotlin code. Right now, our developer API is Kotlin, and we have ambitions of supporting more languages in the future. So for every single resolver with the schema as a source of truth, Viaduct will generate a Kotlin base class for that resolver. So here's an example for the recommended listings field where we generate a recommended listings base class. And this is sort of namespaced under this query resolvers object. And this is called query resolvers because it's named after the object that the field is in, and this happens to be under the query object. So if you notice, within the recommended listings abstract class, there are two functions, resolve and batch resolve. Developers can choose to implement either one of these, depending on their needs. So resolve takes a single context object as input and produces a single output. This context object contains, the inputs to the resolver, such as the field arguments, and also some utilities, which I'll show. So batch resolve, by design, is really similar to resolve. It just takes a list of context objects as input and returns a list of outputs. You may also notice, if you can actually read this code, that each value in the output list is wrapped in a field value. This is basically kind of like a Kotlin result, if you're familiar with that, but it's a union of either a successfully resolved value or an error. And so here now, this is an example implementation of that recommended listings field resolver. So as you can see, you provide an implementation by subclassing the generated base class. And here we can inject the recommendation service API client into the class and use that within our resolver. Then you choose to implement either resolve or batch resolve. And in this case, since the recommendation service doesn't provide a batch endpoint for this, and we also don't suffer from the N+1 problem, we're going to implement resolve. And the implementation just calls the recommendation service, gets back a list of listing IDs, and creates listing objects for each of those IDs. So zooming in a bit into how we create these listing objects. So Viaduct uses global identifiers, and we have this global ID type that consists of two parts, the node type name and also the internal ID of the node. And then now that you have this global ID for the listing, you can use context.nodeFor to create what we call a node reference for that node. And this node reference tells the Viaduct's engine to basically invoke the node resolver and any field resolvers it might need to call to resolve this node. In Skevy's talk, he talked about, one of the common pitfalls of monoliths is you have these entangled dependencies, and how Viaduct avoids that by having these tenant modules with really clear abstraction boundaries. And both Rami and Skevy showed our reentrant API, which I didn't include here, but it basically lets resolvers declare their data dependencies as GraphQL fragments, like similar to Relay. And this node 4 is kind of like another example of how we avoid these interdependencies between modules. Let's say that this recommended listings resolver lives in a recommendations tenant, and the listing resolver lives in a listings tenant. This tenant doesn't need to reach into the listings tenant in order to resolve the listing object. It can just create a node reference, and the engine will take care of resolving that. All right, so now let's take a look at node resolvers, which are very similar to field resolvers. Again, we generate a base class, which is shown on the right side. So this is for the schema on the left, which, there's a listing, and the node resolver is responsible for resolving all the fields under the node without their own field resolver. So in this example, it's responsible for the title field, but not the images field. And again, we have both a resolve function and a batch resolve function, and you can choose to implement either one. So here's an example implementation for the listing resolver. As you can see, again, it implements this generated base class. And in this case, we override batch resolve to solve the n+1 problem. It gets a list of context objects as input. And then it returns a list of listing objects as output. And crucially here, rather than having to call a data loader, we can directly call the listing API client in order to fetch the list of listings. There's no need to create, register, or call a data loader. So here's a diagram of what this looks like. As you can see, the tenant developers only need to write and maintain the blue components, which are resolvers. And under the hood, we still use data loaders. So Viaduct's engine owns and maintains this internal data loader that batches the calls to before making a call to the listing batch resolver. Contrast this with the state where the tenant developer has to be the one worrying about writing and maintaining the listing resolver and the data loader. So yeah, batch resolvers are an ergonomic alternative to data loaders. So aside from ergonomics, another benefit of centralizing where these data loaders live and tenant developers not having to worry about them is that the engine can optimize batch loading. So this is the same diagram that I showed previously. Highlighted in yellow is the component that the engine owns, and this is something that we can use we can apply heuristics to sort of optimize how we construct these batches. So full disclosure, this is still experimental. We're still trying to figure out what heuristics to apply and in what situations, but I'm going to give you an example. So at Airbnb, it's really common to have selective resolvers. So imagine that you have a service like this example, the user service, that is selective. So just like GraphQL, it lets you specify what fields you want to fetch in order to avoid overfetching. So in this case, when a query comes in for a user and the query only includes the user's name, we want to only fetch the user's name. And the node resolver within Viaduct can do so by getting the client selection set from that context object that's passed to both the resolve and the batch resolve functions. So now consider this more complex query that fetches the same user but with different selection sets. It may seem a little bit contrived to some of you, but this is super common in a more complex query that powers an actual page on Airbnb. So, suppose one component only requires the primary host for a listing along with their superhost status. And another component requires all the hosts along with their name. So in this combined query, we're querying, as you can see in the response on the right side, this listing only has one host, user 123, and we're fetching two different selections for this user. So in this case, since we own and manage this internal data loader, we can merge the selections for user 123 and then put them into a single context object before calling the user node resolver. And so in this case, you can see we've merged selections to include ID, name, and superhost, and then so that can just make a request to the user service to fetch all of those fields. And yeah, the last thing is, in addition to batching, at this point you may be wondering, data loaders also handle intra-request caching. What about that? Since we're abstracting away data loaders from this core developer-facing API, Viaduct's engine also handles intra-request caching. So this allows us to support these more advanced use cases like the selective resolvers. So for example, if your element in cache for user 123 has, it's fetched some number of selections and another request comes in for the same user, but with a subset of those selections, we can know that we can extract that element from cache and use that response instead of making another request. The other interesting thing is data loaders, although they handle batching and caching, they're kind of actually two separate functions that happen to be coupled in the same mechanism. So, oftentimes we tell developers use a data loader if you need batching, or if you maybe don't need batching, but you might need intra-request caching, which is, makes things even more confusing. So because we've abstracted away data loaders, we can sort of decouple batching from caching. And this allows us to do things like, for example, unbatched node resolvers can also be cached, and we handle all of that within the engine itself. So in conclusion, batch resolvers are easy to understand because they're very similar to unbatched resolvers, and it also allows Viaduct's engine to optimize batching. Yeah, that's it for me. Like I mentioned, we're super excited to be open sourcing Viaduct in the next week or so. And we will also be hiring a open source specific role at Airbnb. So if anyone is interested, the post is not up yet. We tried to get it up beforehand, but didn't work out. But check our careers page in the coming weeks. Also, I have some stickers in the front, Viaduct stickers, if you want one of these cool ones, like the one on my laptop. So feel free to grab one on your way out. All right, any questions? Yeah.
How are these batch resolvers dispatched?
How are they dispatched? Yeah, we use the same mechanism that we use in Viaduct Classic. So we have a whole data loader infrastructure, and we've sort of just borrowed that and stored it internally. But we have a next-tick dispatcher that Skevi wrote. And so if you have any questions about that, feel free to ask him after. Yeah, yes.
So if you do request caching or caching of a listing, how do
Mm-hmm.
you handle different contexts of that caching? For example, you might want to cache the listing on a detail view, but not when you edit the listing, so you always get the newest version. Is there something that you can handle in the engine?
So are you talking about caching between separate requests?
So different types of requests, but using the same data in different contexts.
Yeah, so we don't do that right now. We only do intra-request caching. So within a single request, we will cache data from our resolvers. We do have, Viaduct as a whole does have a query cache that will cache an entire document, but we don't have this at the resolver level currently. Yes? Mhm. Sorry, could you repeat that? Um, so you mean within a request if it becomes stale? So we don't handle that right now. So we have some mechanisms. So it depends on, so for example, for mutations, we use a stronger consistency to read data from downstream data sources after performing a mutation. But on query operations, we basically just have eventual consistency for that data, and it's possible that the data changes during the middle of the request and that data becomes stale, but we just deal with that difference. Yes.
For the merging of the selections across, like you're merging selections across sibling selections, right?
hmm
Do you do that on per ID within the batch
Mm.
resolver, or is it pre-merged for all instances? Like
Mm.
okay, we're going to hit user, it might be the same user, so just get all the fields.
Yeah, that's a really good question. I don't think we've figured out exactly what to do in that scenario. And, again, it's heuristics. Some might work, like we might want to merge selections across IDs in some scenarios. In other scenarios, we might want to restrict that to just for a single ID. And that's something that we're still experimenting with.
Same question as Matt.
Okay. Yes.
Have you considered just like dropping the single resolver and always have the developers like implement the batch resolver so that they cannot forget implementing the batch resolver?
We haven't, and that's because for Viaduct in particular, batch resolvers are not always the most like you don't always need batch resolvers. Specifically, if your resolver doesn't do any I/O. A common use case for resolvers in Viaduct is like a derived field, which is like all it's doing is it's taking data from other fields in the schema and using that to construct like a new field. And in that case, there's usually no reason to implement a batch resolver, and then that kind of simplifies your implementation code a bit. Yeah. Yes.
Are these batch resolvers mainly used on the edge, or are you also using this in online services? Because the data loaders are quite handy when you push them down near the business logic, right? So that you can just access the fetch functionality there. And you don't have to worry about n+1 problems when you have to fetch a dependency to validate access and something like this. With batch resolvers, you essentially don't have these features in the business logic. Essentially, the GraphQL layer calls directly the business logic with a range of things that they have to resolve, right? So is it something that you may use at the edge to then call downstream services or REST or gRPC or whatever? Or is this also something that you use in your self-code?
Yeah, so Viaduct actually, like one of the things that we aim to do is to like host business logic and host application logic. So it's a pretty thick layer at Airbnb. So we have kind of different use cases for Viaduct resolvers and schema types. We have sort of like a data or entity layer that's sometimes it just directly calls the database, and that's where you probably are going to see most of your batch resolvers. And then we have these more presentation layer that's used to basically, it mainly does derived data computations, and it will, get data from the data schema and sort of present or alter this in a way to enable our presentation use cases, so like our product pages. And typically that's when you don't really see people using batch resolvers, but all of this happens within Viaduct, which is a monolith. So it's all within like a single server. Yeah. Cool. Any other questions? All right. Thanks, everybody.